Hi everyone, Krishna this side. So yes, I am again trying to re-upload the same video which I recorded in the morning, and I again took the second take as well. There also I faced some glitches, and I hopefully at this time I'm not facing any issues and the recording will be happen properly. So what I'll do is I'll divide this video in three different parts or two different parts, so that if I notice if screen is getting freezed, I can stop there itself, and next part I can explain you guys. Okay. So let us try to look into this same problem again in the third time, because I already wasted a lot of time to explain this particular solution. So yes, let us directly jump into the problem statement what we have given. So you are given three integers n, m, k. A good array of size n is defined as follows. Each element in array is inclusive from the range 1 to m. So whatever the m value that we got, it should be whatever the array elements that we have, that should be having these values from 1 to m only. Okay, exactly k indices I where I less than actually equals to n and it is greater than equals to 1 satisfy the condition array of I minus 1 equals to array of I. Okay, so we should have k pairs, okay, k indices from this given array, which will be having this condition. So whatever the addition values that we have, those should be equal. So we need to return the good array that can be formed. Since the answer may be very long, we have to return the module of 10 to the power of 9 plus 7. So it is good problem, and with solving this problem we can get multiple mathematical concepts and we can use them in different problems. Okay, so yes, stay tuned till the end of this video. I'll make sure to explain you best as possible. So the example is n equals to 3, m equals to 2, k equals to 1. These are the different values that we have. So the array size is basically 3. Okay, whatever the array that we are trying to create, the range from this arrays, whatever the elements that we are putting inside one are actually 1 or 2. Okay, with the help of those only we can create the array, and k is actually 1, so there should be one pair, the addition pair, which will be having equal values. Apart from that, there shouldn't be any other pairs, okay, which is having addition values as equal. Okay, that is something what we have to take care of. So in this one is actually equal, so k is got satisfied. Now next element shouldn't be actually equal to this one. Same goes with this pair as well. Two are equal, so here we can fill out with whatever the remaining element that we have in the purse. That is something what we have to fill out. Okay, that way we can create all the different possibilities. So here from this one we get four different possibilities. So I'm not going to jump with another example. I think you should be having pretty much clear idea about the question, because it is actually really frustrating to make videos three times, and I already spent like in the first video I already spent 1 hour to make the video properly. In the second video I tried explaining in 30 minutes, but there also I faced issues. So now let us try to divide it into parts, and let me try to derive the formula that we can generate from this one. Okay, let me connect this one. Let us run this, and let us focus on this particular screen. So yes, just I'll do is I'll quickly generate few of the formulas, like we can derive few of the formulas from this one. So let us see here. The first example is we have this one. Okay, basically n is, let us suppose if it is equals to 4. Okay, and then there is m, basically let us suppose if it is 2, and then there is k is, let us suppose if it is equals to 2. So we have four places in the array. Okay, in these four places we have to create two pairs. Okay, two different pairs which will be satisfying the condition, which is like the adjacent element should be equal, and rest all the elements shouldn't have the adjacent elements equal. Okay, so we have range from 1 to 2. Okay, 1 and 2 are the elements that we can fill into this array. Okay, now what we can do is, like in this array, if we look, the first pair we can create is right at this location, the second pair we can create is at this location, the third pair we can create is like this location. So out of these three locations only we have to create two pairs, correct? So that can be anything, we have to pick any two different locations. Here we have to choose the locations. Okay, two different locations are something what we have to choose. Those could be anything. Okay, out of these three, how many ways we can pick? Two ways we can pick. Okay, so this basically falls under the combination problem, and just we have to have understanding about the permutation and combinations. We already have learned these permutation combinations in math during 11th or 12th. So both the concepts should be clear, we will be having clarity. So see, in the permutation, right, like whenever we are considering if the problem is basically fall under the permutation or combinations, we have to just check that if there are any arrangements or positions really matters in the problem. Okay, If that is the case, we have to consider that problem into the permutation. So the permutation formula is different, and for the combination it is like we can just have to select or just have to choose from the given locations. Okay, so here we have three different locations. Out of these three different locations, we have to pick any two of them. Okay, so what are the possibilities? Let us suppose like this is the first possibility. Okay, here and one is actually left out. Okay, this is the first possibility. Second possibility is like here and here, so these two pairs are also possible. This is the first pair, this is the second pair. The third pair is like the first element is actually filled out with anything, and these are something got filled out with something. Okay, so these three possibilities. Okay, so apart from these three possibilities, are there any ways? Okay, so out of these three pairs, we are actually trying to pick two different locations. Okay, two different locations and filling out with some values. Correct, that is something what we are trying to do. So yes, so what is the combination here? Basically, this is basically falling under the combinations, and I already explained that if we have to choose locations, okay, whatever it may be, if we have to pick and we are not bothering about the arrangements or positions, really doesn't matter. Here we are not bothering about the positions, right? Like we can pick any of the positions out of these three and make two pairs. Okay, and for that three different possibilities are something what we are getting. So the formula for permutation is like 3 factorial divided by, okay, 2 factorial, whatever the value here we got, into 3 minus 2 factorial. So 3 is basically whatever the n value we have. N is basically 4. So from the 4 we have n minus 1 pairs we can create. In that n minus 1 pairs only we have to pick any two of them. Okay, that is the best way we can think of. So out of these three different pairs, we have to pick any two pairs. So how many possibilities are there? So I already showed that like these are the different possibilities that we can get. This is the first possibility, second possibility, and third possibility. Three different possibilities that we are getting. Okay, so that is something what falls under the permutation. Sorry, combination. So combination formula is, let's suppose here it is n minus 1, correct? Because three pairs are what we are getting out of this four. So n minus 1 c, whatever the k value is we have. So n minus 1 c k, that is the formula that we can get. So n minus 1 is basically here it is 3 factorial, and it is like n minus 1 factorial divided by k factorial into n minus 1 minus k factorial. That is the formula that we can get it. Okay, so simply we derived it like how many ways we can pick any two locations from the three locations. Okay, 3 is the answer that we should get it by solving this one. So 3 factorial is basically 3 into 2's factorial. Here k value is 2, 2's factorial into n minus 1 minus k. So it is like 3 minus 1 minus 2 is basically 0. Correct, zero's factorial is basically always zero's factorial equals to 1. That is something what we have to remember. Okay, 3's factorial, here 2 factorial got cancelled. 3 is something what remained. Zero's factorial is basically 1, so it is 1 ultimately equals to 3. Okay, 3 is the answer that we got so far from here. Okay, and that is something what we actually check also. Like here this is the first possibility, right? Here only we can create the pair. So let us suppose a is something got fit, here it is b. Okay, in the next one a is something got filled, here b b. Okay, a and bb are something like we are taking it from this range. Okay, the m range that we got already. Here in this one what we can do, here a can be filled, b can be filled. Okay, this way like three different possibilities we are getting. Now the question is like how many values that we can fill in these three different possibilities that we have, right? So range is like 1 and 2 are the elements that we can fill across these three different possibilities. The first possibility that we can get is like 1 1 1 2. Correct, that is the first pair that we can pick, as I already explained. And again we can convert this into like 2 2 2 1. Correct, this is also another pair. So next is like here 1 1 2 2 or 2 2 1 1, that is also possible. Next one is like 1 2 2 2 or 2 1 1 1, this is also possible. So in total 6 possibilities are happening. So at all the locations, different locations that we have, we are actually multiplying it with m. Okay, because from n either we can pick 1 or pick 2. Okay, if m value is basically 3, from 1 to 3 is something what we have. Okay, then possibilities is like 3 into whatever the value that we got from this code. Okay, the formula that we derived, n c k, whatever the value that we have. Currently m value is 2, so 2 into whatever the answer that we got. 3 was there, so in total 6 pairs is something what we got, right? So that is something what I already explained to you, like how the pairs are forming. So whatever the m value you have, so those values is something what we can fill out in different locations and we can get the answer. So in total it is like m into n minus 1 c k. Those are the possibilities that we can get. So the formula that we can generate is like m into n minus 1 ck. This is the formula that we can generate so far. Okay, now the point is here, see, if m value is 3, so 3 values we can fill out in this array. So those are like 1 1 1 2, okay, or 2221, or 33331, okay, or 1113, correct. These are different possibilities that we are getting, right? So in total, like, they are getting increased now. In this case it was only 6, okay, in this case those are only 6. So what is like 2 into whatever the answer that we got, that is something what we are doing, correct. But here now it is getting increased. So whatever the m value that we have, those values we can fill out in this one, and we can, whatever the combinations that we got, with those combinations we can multiply directly m. So far the answer is like m into n minus 1 c k. That is the answer that we got so far. Okay, now the problem is, again we have to see like what are the left out elements that are there. Okay, so left out elements can also be getting filled with anything. Okay, so we derived this formula. So let us suppose if the pair is actually got filled with something, now the remaining element, that whatever we have, that is something that needs to be get filled. So in this particular code, we are not getting left out with anything. Okay, we are actually filled out with something. So what if they, basically what I'm trying to say is, whatever the value that we have in total 4 pairs, out of that 2 pairs are something what we filled. So remaining indices something what we have to take care of. Okay, so whatever the remaining indices that we have, so let us say here, just think about this. I'm just trying to take as quick as possible, because after a certain time the screen is getting freeze and it was really frustrating. So uh, just fast forwarded, try to understand what I'm trying to say. If still getting questions, you can ask me in the code, okay, into the comments. I can answer you guys. Okay, so far we got this answer. Okay, these are different possibilities that we can get. So now see, k indices got filled. Let us suppose n is actually equals to 4, k is basically equals to 2, and m is actually equals to 3. Okay, so let us suppose n is actually 4, so n minus 1 minus k indices are still left. Okay, what I'm trying to say is, see, 2 pairs is something what we have to create. So this is first pair we created, this is second pair we created. Okay, two pairs we have created right now here. So what are the left out pairs, I mean left out indices? 4 minus 2 minus 1, so it is basically 1. So one indices is actually getting left out. Okay, let us suppose if m is actually equals to 5, so in that case 2, it is like n minus 5 minus 2 minus 1. Okay, because 3 indices are something what already got filled. So n minus 5 minus 1 is actually equals to 2. So 2 indices are actually getting left out. Okay, these are getting filled with m. Okay, that is something what we already noticed right over here at the top. Okay, those values actually got filled with m. M into n minus 1 ck is the formula that we derived, n minus 1 ck. Now for all these left out indices, we have to fill something. Okay, we have to fill the information with something. So this is something got filled with m. Okay, so for this value is something got, let us just derive it in quickly. So this got filled with m. Whatever the remaining indices that we have to fill the data as well, and we have to make sure that no two Artisan elements are equal now, because Artisan elements equal possibilities we already something got figured out. Okay, so let us suppose m is actually equals to 3. So 1 2 3 is something what the information that we have. So this m indices, if let us suppose we filled out with 1 or 2 or 3. Okay, let us suppose we filled it with 1. So what are the possibilities of filling this particular one? It is basically 2 or 3, correct? Correct. See, one is already got filled. Now I cannot fill this one with one. I can either pick 2 or 3. Any one of them is something what I can pick. Correct. Now at this particular location, next location, what is the possibility of filling the element? So it is like either 1 or 3. If I pick 2 as this particular index element, okay. If I pick 3, it will be 1 or 2. Correct. So what are the possibilities if this got filled with m? This is like m minus 1. Out of the m minus 1 elements, I can fill this particular index. Okay, for this one, how many possibilities it is again like m minus 1, my right? M minus 1 only possibilities. If still there are few of the indices that are there here also, I can accept whatever the element that was filled are recent like. So we can leave that one, and whatever the remaining values that we have in the m, those values we can fill. So there are possibilities like m minus 1 so on till n minus k minus 1, all these indices until we fill whatever the remaining indices that we have. If there are no remaining indices, whatever the power, let us suppose if we are still not having any indices, the power of 2 is basically 1. So 1 is something what we can multiply. But if still there are few of the indices that needs to be filled, so this value is something what 3 indices something what we have to fill. So it is like m minus 1 into m minus 1 into m minus 1, these 3 different possibilities that are there. So it is like ultimately we are deriving m minus 1 to the power of n minus k minus 1. Okay, so this is something what we have to again multiply right over here at this locations, whatever the previous formula that we got, m minus n minus 1 ck into m minus 1 Okay, it is actually lagging, and I can notice it, n minus k minus 1. So that is the formula that we can get. So ultimately we have this formula now. We have to basically get the factorials of the numbers, and we have to get the power of numbers also. So these values we already have. This is the formula that we have, and this is something what we have to solve. Now we actually derived the formula entirely, and let us look into the code if possible. If it is getting freezed out when you notice the code, when you try to read the code, if it is getting freezed or I notice that code is getting freezed, I'll make another video. But I'll just quickly walk you through the code, and yes, you can try it out different things, okay, with the code. The first thing is like we are trying to get the factorial of the numbers, because that is really important. Okay, in the formula it is like n minus 1 ck. It was like n minus n minus 1 factorial divided by k factorial into n minus k minus 1 factorial. Those values something what we have to figure out. Okay, the first thing is like get the factorial of the numbers, and since the answer is pretty much long, so whatever the factorial of any particular number into I, if it goes beyond integer values range, because I is basically int, so we are actually making it mod. So whatever the answers that we are getting, we are actually storing based on the mod values. Okay, so yes, this way we can get a factorial of a number. And again, if you are struggling with getting the factorial of number, inverse factorial of a number, so we are actually storing the inverse factorial of a number also, 1 divided by r's factorial, something that we have to get it. And to get that one, this is the Fermat's little law, Fermat's little theorem. This is the theorem that I am applying right over here to get any inverse, whatever the inverse value that we have, to get its value. Okay, 1 by r factorial is something what we have. So that is something what we are deriving it. And again, if you struggle with this for loop, let me know. I can explain you in the comments. I can try to explain, or still if required to explain this entire code properly, I will make the different video and I'll explain each code line by line. Okay, inverse factorials also we got. N factorial is something what n minus 1 factorial, we can get it from this particular array. Whatever the r factorial or n minus r minus k factorial value that we have, n minus 1 minus k factorial, those we can get it from the inverse of factorial. So whatever the inverse of factorial that we have, we can multiply it with the factorial of that number. Okay, so it is like n minus 1 factorial value that we can get it from this factorial array. And whatever the answer that we got, we again multiply with this case factorial value, and inverse of value of n minus 1 minus case factorial of value. So that way we can get the n c k, n minus 1 c k, that answer we can get. Now we have to multiply it with m minus 1 to the power of n minus k minus 1. So that is something what we are deriving it from this particular function. So this function basically takes log of n time. Okay, and the same operation we are doing it while doing the getting this factorial of the last index. Once we get the last index factorial, we can basically multiply it with the same value to get second last value, because that way we can just cancel out the values. So let us suppose 1 divided by 4 factorial is something what we derived from this one. So to get 1 by 3 factorials answer, what we can do, whatever the previous answer we got, 1 divided by 4 factorial, we can easily multiply it with 4. Okay, 1 divided by 4 factorial into 4 is basically 4 get cancelled out. So 4 factorial is basically we can denote it into 4 into 3 factorial. So 4 get cancels out, 1 by 3 factorial is something what we can get. So that is something what we are doing it by going backward and multiplying with the previous values, whatever the factorial that we got with the same value. Okay, and this modPow is basically going to be this Fermat's little theorem. So yes, again, if you need a video about this one, or about this how we are getting this log of n times to solve the to get the power of any number, that I can explain you in another video. But we have to get clarity about how we can get it any numbers power in log of n time. Okay, so yes, I'll explain you. If you make comments, I can explain you guys this particular functions, different functions. So I'm just deriving the all the values. Okay, so with this one I can get it m minus 1's power of n minus 1 minus k value. Okay, once I get that, this is basically taking log of n time, this is basically taking log of mod time. Okay, and these all different functions are taking log of n times. And at the end, whatever the result that I get, I am multiplying with m into power of value into whatever the nck, the answer that I got. Okay, and at the end, I have to make sure that each time I have to apply the mod whenever I am multiplying any two different values, to make sure it is not going out of bound. And whatever the result that we got, we are converting into it and returning it. Okay, that's how we can write the code. So it is like space, it is like 2n space we are using, and n into log of n plus log of mod, because mod value is actually bigger. So n plus log of mod is the answer time complexity that we are taking it for this one. Okay, So that's how this code actually works, and I couldn't explain you this code because the screen got really freezing a lot. And in the morning video I actually written down this code entirely, but the video actually couldn't, I mean it got some glitches and couldn't make the video properly. But yes, if you want proper derivation of each of the formula, how we are actually getting the power in log of n time and all, let me know. I'll create another video and I'll explain you guys all these different things. Okay, this whatever the Fermat's little theorem and all to get the inverse of factorial of a number. These things I can explain you in another video. Okay, so thank you for watching this video. Bye bye.